Okay, so in this lesson we'll be learning how to differentiate the trig functions and also the exponential and log functions, and we'll begin with the 6 trig functions. That's sine, cos, tan, cot, sec and cosec, and we'll be just giving the results. We won't be proving anything in this lesson. That will come later on. So to begin, the derivative of sine x is cos x, and this you just have to memorize. Sine x becomes cos x, and when we differentiate cos x we get negative sine x, and when we differentiate tan x we get sec squared x. And the square here, the 2, what that means is the following: sec x all squared. So you should already know that, but I'll just put that down. And this is the usual way to write it, sec squared x. And the derivative of cot x is negative cosec squared x. And the meaning of that is negative and then cosec x all squared. And then the derivative of sec x is sec x tan x. So we normally say sec tan, and be careful not to miss out this x. When you do that, it is sec x tan x. And the derivative of cosec x is negative cosec x cot x, and we normally say negative cosec cot, but be careful not to miss out the x. Okay, next we're going to differentiate the exponential functions, and there'll be 2 types. You'll have the normal e to the x, and also other exponentials where it's a different number, like a number 3 or a number 6. So we'll begin with the derivative of e to the x, and that's just e to the x. So when you differentiate the exponential, you just get back the exponential, the same one. And for example, if you want to differentiate 7e to the x, you just get 7e to the x. So the 7 just multiplies e to the x. And the derivative of minus half e to the x is just minus half e to the x. So that's that. And what if we don't use an e? What if we use some other number, like a 3, or in general any number bigger than 0? The result, just like when you differentiate e to the x, you get e to the x. If you differentiate a to the x, you get a to the x still, but we do get an extra factor, and that factor is going to be ln a, or ln a. So that's just an extra factor that we get when we differentiate an exponential that the base isn't an e. The e itself is just a number. I'll put it down. E is a number. It's 2.718, and it goes on. So that's a special number, and we call it e. And any other number, when you differentiate, you do get an extra factor of ln a. So for example, to differentiate 3 to the x, you get, because it's an exponential, you get back 3 to the x, but then you also get an extra factor of ln 3, or ln 3. If you want to differentiate 5 times 6 to the x, you get 5, and then you get back the exponential, 6 to the x, and then you have to add on ln6 or ln6. Okay, next we're going to differentiate logarithm functions, and there'll be two types. You're going to have the natural logarithm, ln x, and also general logarithms, log, say, to the base 5 or base 3, or in general base a. The natural logarithm, ln x, the derivative is 1 over x. That's all there is to it. So when you want to differentiate 7 ln x, you get 7 times 1 over x, which is just 7 over x. And if you want to differentiate minus 2/3 ln x, it will be minus 2/3 multiplied by 1 over x, which I can put in the denominator. Okay, so what about more general logs when it's log base a of x? So just as with the natural logarithm you get a 1 over x, you also get a 1 over x, but now we get an extra factor, and that extra factor goes at the bottom, and it's going to be ln a, and that's the rule. So for example, if you want to differentiate log base 5 of x, it becomes 1 over x, just like the natural logarithm, but we have to add in a ln 5. If you want to differentiate 2 log base 3x, you're going to get a 2 over x as if it was a natural logarithm, and then you get the extra factor ln 3. Okay, example number 1. We're given a function y equals 4 sine x minus 3x squared plus 6e to the x plus 5 cosec x, and we need to differentiate. So dy dx, and we differentiate it term by term and just multiply by the coefficients in front. So sine x becomes cos x, so we have 4 cos x. This is a normal polynomial, so it becomes 6x, and then e to the x becomes e to the x, so we get 6e to the x, and cosec x becomes minus cosec cot, so we have minus 5 cosec x cot x. Okay, example number 2. We're given a function f of x equals cot x minus 5 ln x plus 3 sec x plus x to the 7, and we need to differentiate it. So f dash of x, so cot x becomes negative cosec squared, so negative cosec squared x. Ln x becomes 1 over x, so we get 5 over x minus 5 over x, and sec x becomes sec tan, so we have plus 3 sec x tan x, and this we can just differentiate 7x squared. Okay, question number 3, we need to differentiate 2 sine x plus 2 times 4 to the x plus 11 log base 5x minus tan x. So we begin. So we know that sine x becomes cos x, so we get 2 cos x. The 4 to the x will become 4 to the x ln 4, so we have a 2 4 to the x ln 4, and the log base 5 of x will become 1 over x ln 5. So we have 11 over x, and we add the factor ln 5. And minus, and we get tan x becomes sec squared x. So sec squared x.